everyone, I am Pragna and I'm currently working as a technical lead at Twilio right now. And I've been with Twilio for about 4.5 years now. And before Twilio, I worked with Yahoo and AWS and Cerner. So today I'm very excited to be here to talk about our journey of how we migrated our Monolith to workflows. So my focus of the talk is mostly going to be about the challenges we've faced before Temporal, because you've heard a lot about all the amazing features that Temporal offers. I'm going to mostly rant. So, as most of you already know here, Twilio is an innovative customer engagement platform. So essentially, you can engage with your customers, communicate with your customers on different channels like voice, video, SMS, and email. And Twilio makes it very easy for you to integrate. We integrate with your customer to engage. I particularly work on the messaging side of Twilio, and basically the SMS. If you ever received a message from Amazon saying your order's probably on the way, or DoorDash that your food is right at your doorstep, then probably those messages were powered by Twilio. Now, when you think about SMS, the most annoying bit is all the spam that we've been getting. I mean, at this point of time, I almost ignore my messages, SMS. And attackers are getting really creative with their attacks. On the side note, smishing is actually just phishing over SMS. So there's been a huge increase in smishing attacks and lots of spam. And obviously, we're all pretty annoyed about it. So there comes the A2P messaging compliance initiative. Essentially, this initiative is started to combat spam and smishing and to regulate the SMS traffic. So a part of the A2P compliance initiative, essentially this little story behind this is all the entire telecommunication ecosystem got together, like Verizon, T-Mobile, Twilio, and all of these people, and they're like, we have to make something happen, and we have to stop spam and smishing attacks over SMS. And we need to make SMS more a reliable channel. So this is where it's coming from. And in 2021 is when A2P compliance initiative started. And so A2P compliance is essentially you as a customer, if you want to send messages to your customers, then you are supposed to register yourself with different entities in telecommunication ecosystem. Like you have to, let's say you have to register yourself with like Verizon, T-Mobile. You have to say, hey, if, for example, I'm a pizza shop, I have to go register myself as, hey, I'm a pizza shop. That's brand registration. Essentially, you're registering your brand and your company. And the next is campaign registration, which is basically explaining pre-registering. This is all happening before you even start sending the messages. So you're essentially explaining, I'm a pizza shop, and my use case is I want to send delivery notifications to customers or two-factor authentication messages to customers when they sign up on my platform. That's a very valid use case for my pizza shop. So that is campaign registration. And the next bit is number registration. And now I'm saying, hey, I'm going to use these 10 numbers, only these 10 numbers to send these probably my delivery notifications. So that is number registration. So in a nutshell, the three important concepts are before allowing someone to send messages over SMS channel, there are three things that we're trying to do is understand who is sending the messages, what type of messages are they sending, and do they have consent to send those messages. Essentially, when you sign up, there is a little checkbox that says, I'm willing to get notifications about this order, or I'm willing to sign up for any offers. And then the third concept is numbers, where you're saying these exactly are the numbers I'm going to use. So it's all pre-registered, pre-configured, and we're only going to allow customers that are legit. So far, everything looks really good. There was a problem, and there is compliance to regulate that problem. So what exactly is the problem? And the reason I'm here. The problem was our architecture. So let's take a small example. Like we have different registration workflows, but let's take a small example of one of our registrations. And our registration comprises of 1 to 10 steps. We have campaign being created by the customer, and then campaign being submitted for a manual review that someone has to manually review and say, hey, this looks good. A Pizza Hut shop doesn't needs a delivery notification as a use case. That's legit. So someone's manually clicking it. And then we pass it on to the other third parties in the ecosystem like Verizon, Telecom, T-Mobile, and all that. But our architecture didn't look at our registration process as a sequence of steps. But in fact, our architecture looked at it as, I got an event X, which is I got an event saying, hey, the campaign has been registered. And the database, I look at the database, and the database is in the state Y, saying, hey, the campaign's registered. So I'm going to take an action, which is submitted for manual review. So our state machine, our entire registration was one state machine, which is one big file with 2,000 lines of code. And our state machine didn't really understand the order of sequence. All it understood is, I got this event X, and the database is in event Y, is in state Y, and I'm going to perform action Z. That's all. So that was the biggest problem for us. Now, so when we were implementing a feature, we couldn't simply think about it as in terms of, hey, there are 4 steps, so introduce a 5th step. No, we had to think in terms of state machines and state transitions, and that thought process was pretty complex and very error prone. For example, if we are expecting a campaign registered event, but a different event comes in, I mean, in production, edge cases happen all the time. Now, our state machine doesn't know what to do with that event because the database, the state is not in the state it's expecting it to be. So there was a lot of code all over the place kind of situation. And the next one is our entire use case is pretty much event driven, and we have a lot of third-party integrations, third-party API integrations. And most of these APIs have rate limits of 1 or 2 requests per second. So we go over that, we get throttled by our third-party APIs. So the problem what happened with that is there were different signals coming into the state machine. One signal saying, hey, Verizon accepted your campaign, or another signal saying AT&T accepted your campaign, or another signal that says your campaign has been manually approved. Someone went and said approve on the dashboard. So there are different signals coming into the state machine. And as I mentioned, state machine doesn't really understand the ordering of things. So there's a signal here, there's a signal here, and then the code was all over the place, and it was really hard to piece the workflow together. One of the onboarding things I used to do when we had new engineers on the team was basically explain go walk through the entire code base and architecture and everything, and give them a day to track the code all the way from registration step 1 to the end of the registration, and they would get lost in between. Like it was such a complicated task to even piece together the registration steps in the code base. And our code, all I'm trying to say is that our code was definitely all over the place. And because it was such a complex maze for us, onboarding new people was really hard. And A2P compliance was a very important initiative for Twilio, because you're not compliant which means our customers aren't able to send messages, which directly impacts our revenue. And messaging is one of the biggest revenue makers for Twilio, so the pressure was on. And our engineering team absolutely wasn't scalable. And basically, to add to that, the A2P, our entire ecosystem, the telecommunication ecosystem, the entire regulations compliance is pretty new. It's pretty much, we are integrating with these APIs as they are building these APIs. So there were a lot of changes that are happening in the ecosystem, and a lot of new features that we had to integrate with to make our customers compliant. And our environment wasn't flexible enough to keep up with these constant changes. Now, this is just a piece of code about it's a very simple piece of code. All it does is once the campaign, it creates a campaign. Once the campaign is created, and once a person goes and once our ops team goes and manually approves the campaign, it will receive an event saying a campaign was approved or rejected, and it just updates it in the database. So just plain simple, create campaign, wait for the manual review, and then update the review status in the database. 3 steps. Now, when in our previous architecture, when we had the entire big state machine, you see that the handle create campaign and handle review received, they're pretty concise methods, it's all good. But there is no connection between them. They're both disjoint. They're just executed when a certain event is coming in. And so now imagine applying this concept to a registration with 15 steps. There is no piecing together what comes first and what comes later, because they're all just disjointed actions that are thrown in the state machine. Now, if you took a snapshot of our situation in late 2021, early 2022, our code base felt like this, because our team took ownership of the code base around in 2021. And there were so many deadlines, and deadlines were looming over us. And the thing about deadlines in compliance ecosystem is that they are compliance deadlines, so you can't really push them. There is no concept of not meeting the deadlines. And our third-party vendors were having degradations and then outages for hours, and then we were scrambling through the logs to understand the impact on our customers and all that. And this was us. So I'm not done with the ranting yet. More. So more architectural challenges that we could bucket into like these 5 different areas. First one, state management. Taking a simple workflow out, let's say I would take a campaign registration. The problem with our old architecture was we had to do everything. We had to, if there are 15 steps, we had to basically go update every stage in the database, saying, hey, I'm in step 1, updated in the database. Hey, I'm in step 3, updated in the database. And you understand. So, and also not just persisting our state in the database, also configuring our state machine to handle an event in different states. Like in a happy path, we expect a campaign registration workflow, a campaign registration manual review approval to come in when the database is in waiting for manual review phase. But in production cases, there are always going to be edge cases where we get some out of order events. And our state machine had to be we had to manually write, this is the state, and if an event comes in this unexpected state, do this, or if an event comes in an unexpected state here, do that. So it was hard. State management is really hard when you're doing it yourself. But wouldn't it be nice if something came in and abstracted this entire thing away? Now, the next one is resiliency. Now, resiliency and handling retries became a huge overhead. Now, remember that we were racing to meet deadlines, and remember that this was a new code base that we're still like trying to understand this thing. Now, if a lot of the times making our workflows resilient or even introducing retries became such a huge overhead that writing the functionality actually took lesser time than actually going and writing the retries, handling the retries and making our workflows resilient. Now, there were a lot of inconsistency in how we handled retries. Sometimes we had to store the retry count in the database, saying, hey, I retried once, update in the database. Very frustrating. And sometimes we had to use messages, like the queue messages, and embed saying, hey, I've retried 100 times. I can go probably 10 more times. And also, since again, the whole this compliance ecosystem is relatively new, so there were a lot of times where our third-party APIs were completely, there was a huge outage on them for a couple of hours. And we had to retry almost, while the third-party APIs are down for a couple of hours, our customer request gets queued in. So essentially for our workflows to recover, it would take a day or a day and a half. So our retry count has to be so high that our retries would happen even after 2 days. So it was a lot of overhead and thinking for us to do to ensure that we provide resilient workflows to our customers. Oh my God, traceability or auditability. The countless number of hours I spent digging through the logs to understand something. If a customer comes and says, hey, why is my campaign in this state? It's not supposed to be. And then we go dig through the logs to understand what happened. And since, now that you have a little understanding of how our state machine works, hopefully, when we had to like debug something or audit something for a customer, we had to map, hey, when this request came in, the database was in this state, and probably this piece of code was executed. Or thankfully, if someone wrote logs, then we know for sure that piece of code was executed. So this is how we debugged, and it took hours. And the worst part of it all was after doing the entire thing, we would go back and say, as far as I know, this could have happened. And sometimes there is no definitive answer, and it's very frustrating. This is just for one customer escalation, by the way. Now imagine gathering impact if there was a big outage or incident. It made our lives very hard. The next thing was observability. We had to push a lot of manual metrics in the code to understand a lot of these metrics. How many registrations are in flight right now? And how many of them failed? How many of them succeeded? Are we seeing any errors? Or are we seeing any retry actions? So all these metrics, and in some cases, if we forget pushing, if we miss in the code, pushing some metrics out, then our metrics sort of become unreliable. And again, we have to go back and fix them. But wouldn't it be nice if something came out of the box, all the metrics? So at this point in time, things were pretty chaotic. We were pretty burnt out, and we knew there has to be a solution. We knew we have to take a step back and find a solution for this. And obviously, the solution was re-architecture. When we were thinking about re-architecture, we didn't know what solutions were out there. We didn't know what solutions are there that would actually help us. We were ready to build a new framework that would probably help us if there is no solution that fits us. Thankfully, there were lots of solutions out there. So we evaluated Temporal, Apache Airflow, Netflix Conductor, and Amazon Step Functions. And this was our evaluation criteria. So our evaluation criteria was that we wanted workflows as code, which was very important for us because our workflows are pretty complex. Our business use case is pretty complex, and there's a lot of branching logic that happens. If this gets rejected, do this gets rejected, do that. And having workflows as code would help us with writability and also readability. Now, the next criteria was good to have was Java, since our existing monolith was already in Java. And the next criteria was something that doesn't require a complete overhaul of our systems, like where we have to rip the entire code and take 2 years and actually re-architect the entire system. We didn't have that kind of time. And the next thing is, most of our workflows are pretty long running. Some even go up to 3 months or 4 months. So dynamic changes were very important. Essentially, if a workflow was already in flight, and now product comes and says, can you add this one extra step to the registration process in the end, then all the in-flight workflows should be able to pick up that, and that was very important for us. And the next thing was, as I mentioned, all our downstream requests, all our downstream APIs were pretty rate limited at 1 or 2 requests per second. So it would be nice to have something where we can just configure the rate at which it needs to hit the downstream. Because our existing solution was lots and lots of queues. We had we have lots of third-party APIs that we're calling, and we had to queue all these requests up, and we had to make compromises in our request throughput, because we wanted to ensure that we didn't get throttled by a downstream. Now, the next solution was, the next evaluation criteria was managed cloud, because we wanted to focus on building the functionality and meet product deadlines. And a managed cloud solution would be great for us if the infrastructure is being handled by someone else. So we were all ready to go. We had a plan. We chose surprise, Temporal is the one that fit all the evaluation criteria. So we chose Temporal. We knew it was Temporal, and we were ready. We had a plan. We were ready to go re-architect our systems and make our lives better. But wait. We don't have time for re-architecture. We have deadlines to meet. No time. So we had to improvise. So we started small, very small, and we started running in hybrid mode. So, for example, one of the registration processes is 15 steps. So what we did when I said running in hybrid mode is, if we got a product requirement that says add this step in between, like add step 4.2, basically the step after 4 and before 5. Then instead of, even if it's a small change in the existing architecture, we basically added that step 4.2 as a temporal workflow. Essentially, the old code would go trigger the new workflow, new temporal workflow, and execute that new step, and then temporal will hand it off to the old code. So that's how we started running very small in hybrid mode. And this was our re-architecture plan. So essentially, we drew team boundaries. The best part about Temporal was the way Temporal is built, it doesn't matter where the code existed. So we could draw team boundaries and say, hey, these are the workflows we own, so you keep it in your own repositories. Or these are the workflows you own, so you keep it in your own repositories. And essentially, we can go ahead and trigger child workflows irrespective of wherever their code was configured. So that was very easy for us. And then we had our workflow designs. How should the webhooks be handled? How should the registration be handled? Or as Matt was mentioning, how do we queue up? How do we queue up these requests that are coming in different in out of order? And then we had a plan for end-to-end testing, and we started running in hybrid mode. any new initiative that came in, big or small, we said we will integrate with Temporal and will grow because we didn't have time to take a step back and re-architect the entire thing. So the immediate impact was the change in our thought process. In our previous implementations, our thought process when implementing a feature was in terms of state machines and state transitions. Now, Temporal completely abstracted it away. When we were building a feature, all we could think of is simple sequence of steps. This step comes after this step, then we wait for an external signal to come in and proceed with the workflow. Now, as Jim mentioned before, you can actually start coding like you're in college. It was great. I mean, previously it was state machines, state transitions, and now it's just simple sequence of steps. And the interesting immediate another impact that we've seen is that Temporal had a very small learning curve, and teams loved it. Even very small initiative, people were happy to implement that in Temporal rather than doing it in the existing code base. And very fast, I'm really surprised, but very fast, we've seen the entire end-to-end workflows. We started with a small step, 4.2 in a Temporal workflow, but so fast we've seen the entire end-to-end workflows being migrated to Temporal. And we were able to also scale our engineering teams. We had a new, entirely brand new team that was new to our compliance team, compliance org, and also new to Temporal. We were able to onboard them to Temporal very fast, and they were able to deliver a huge initiative in a matter of 1.5 months, which was impossible before, because it would take you 1 or 2 months to just get around and understanding the old code base. So that's the code you've seen before, where all it's doing is simple: create a campaign, wait for the manual review, and then update that status in the database. With state machine, you see how disjointed this is, but with the Temporal workflow, if you look at the workflow method, there's an activity to create campaign, and there's a workflow.await. So essentially, you're just waiting for the review status to be approved, and then you mark the campaign as approved or rejected. It's so much cleaner and it's so much easier. And the best part was most of our code was reusable during the migration. And that's why we've seen so little regressions during migration, because Temporal was essentially sitting as a wrapper on our existing code. Let's see how. So we had logic already written in our old code base to just, it's a simple use case, to basically load a campaign from the database. So all we had to do was write an activity interface and an interface implementation that calls our old code. Essentially, we are not rewriting the code for the migration. We're just, the Tempo is just neatly sitting as a wrapper on top of our existing code, which means you don't have to rewrite what's already written. This was great. Now, how Temporal solved our challenges. We went through the whole state management, resiliency, and all those issues before, but how Temporal solved it? State management, didn't have to think about it. Resiliency, it's a simple configuration file. Just retry 200 times or 300 times with back off and retry. And auditability or traceability. We had this clean Temporal UI that says this is the input and this is the output. So it became very easy to trace a customer's issue or see, hey, this was probably what happened. It became very easy. Now, observability, out of the box metrics. Essentially, Tempo is directly pushing all the activity failures or workflow failures. All the metrics are already coming out of the box for us. So we didn't have to go configure anything explicitly. So I'm very excited about the Datadog integration. I'm going to go back home and try that out. And all we had to do is set up Datadog dashboards and set up monitors for them. That's it. Now, code maintainability obviously became very easy because a lot of these things are coming out of the box, and our code looks much simpler than it used to before. So our code maintainability, or onboarding new team members to the team, or onboarding new teams even, became so much easier. Now, the features that were previously a luxury are the features now we can't live without, are global queue rate limiting, all our third-party registrations, all our third-party APIs which have low rate limiting. All we have to do is simple line. Instead of having multiple SQS queues, all we have to do is set max queue activities per second as 1, and we're good to go. All our downstreams are requested at the rate limits that they've set. I really enjoy this feature because maintaining multiple queues and not understanding which message goes into what queues is not a state I want to be in. Then signaling. Signaling is also super easy. We have this manual approval process for some of our workflows, and where someone literally goes and says approve. So just signaling from there is super easy. And then scheduling. And temporal dashboard, this is my favorite. And temporal CLI, and all these out-of-the-box metrics. So, ending with my key takeaways for the session, some of our lessons learned, more like things we've actually learned, not the lessons learned. Re-architecting with temporal was actually much easier and less consuming than we initially anticipated. I mean, most of the code was reused, and which was causing less regressions. And there was a very small learning curve. And the reason I think it took less time or it felt much easier was because of how much developers loved it. Developers loved it, and we adopted it in every single use case, and we were able to quickly, I think we started the migration in January, and by August, almost 90% of our workflows are on temporal right now. I mean, the remaining 10% are pretty internal, so we're getting there, but we did not expect that it'll happen this fast. And the cost of architecture was definitely worth it, because we're seeing accelerated development so much faster than we could have done before. And code reviews are much easier because you're only touching the code, you're only reviewing the code that someone's changed. It's not like you have to go look at the state machine and understand what else could go wrong. And now, and definitely very easy onboarding. And the last key takeaway for me would be, for every time I have a use case where there is a long-running, and a business use case kind of workflows, I would definitely choose temporal, especially for temporal supporting dynamic workflows, or temporal supporting workflows as code. So that's it from me today. Thanks a lot, everyone. Sorry?
I'll take some questions.
Oh, yeah.
Yeah. So, I'm sorry, this needs to go on again. We're happy to take a couple questions. My troublemaker in the front row, Rajesh again. Irina, can you, I think Rajesh has a question. Rajesh is going to be speaking later, so he and I have been going back for a while.
So, hi Pragna. Can you talk a little bit about your evaluation with step functions? Because we are going through that same journey of evaluation right now. So it'll be helpful if you can throw some light on that.
So for us, when we were evaluating step functions, first of all, step functions was very well supported for services that are already on AWS. For example, if you have DynamoDB triggers, or if you have Lambdas running already, step functions makes it very easy. But for us, step functions didn't allow workflows as code. It had its own language. And also, using step functions meant we had to move our code to Lambdas, which is a huge migration process. But on the other hand, for Temporal is just sitting on top of our existing code. So we didn't have to flip the table, overhaul our code base to do the migration to step functions.
Yeah, don't change the way you think, change the way you work, right? Or change the way you think, not the way you work. And by the way, the whole comment about code like you're in college, that actually came from our solutions guys. But it's kind of true, right? You basically code for straight path through. That really works. I can't take credit for that one, Pragna. Are there any other questions? I'm like East Coast hungry right now, which is like 3:30 in the afternoon hungry.
Hey, I haven't eaten food because I had
I'm with
the
you.
presentation.
Same.
Yeah, I'll be great. Thank you. So you mentioned you basically reuse lots of functions that you previously have. How do you solve the problem where Temporal sometimes, well, most of the time require deterministic workflows? Do you just put them in activities, or do you have any other solutions that can be helpful?
Sorry, if you could maybe rephrase the question. Most of the time, I didn't get that fully.
Like, so previously you have some function you already wrote, right? And you mentioned in your talk that you basically kind of reuse them when you migrate to Temporal. However, Temporal requires the workflow to be deterministic, right? So how would you solve that problem with your existing code? Do you have to modify, refactor all of them, or only some of them, or do you have put them in maybe activities, or what?
So when we were doing the migration and we were running into this problems where it wasn't backwards compatible, we had two options. Basically, we would use versioning, or we would basically, not the best way to do it, but works out for us. When we had too many changes to make in our workflows, we would just clone a workflow and call it V2 and then kick that workflow off. So all our workflows would still be running on V1, while the new workflows will kick off in V2.